Hello, everyone. During my part of presentation, I would like to present you how to use Melodic. In order to start Melodic usage, we need to at first install it on any own environment. I start my presentation from Melodic website, where detailed instruction with all requirements how to install our platform is available. We can download here a text instruction which contains description how to install and configure Melodic step by step. Also, we can find here link to the GitLab repository where Melodic code is available. It is open source, so it is possible to download, use, and also to improve. We can install Melodic on any environment, preferably on virtual machine, but also it is possible to install it on own computer, as it is really secure and easy to manage thanks to using Docker containers. My Melodic platform is already installed and configured on virtual machine on AWS. It is up and ready to use. Now I'm logged in, so now I can describe you how to use Melodic. At the beginning, I would like to describe Melodic users. Melodic users are managed by LDAP. During Melodic platform installation process, users are asked for provide default Melodic admin credentials, username and password. After that, all Melodic accounts are fully managed by UI. And now we are logging as administrator, so we can see this manage users option in menu and list of each type of users after choosing it. We have three possible roles of users. Common user, he can perform application deployments. Admin user, he manages of users' accounts and also has all privileges from common user. And technical user, he is used only internally by Melodic components and he is not important from client's point of view. Administrator has permission to creating new user accounts with auto-generated strong random password or with password provided by him. A new user can log in with credentials created by admin, and after the first login, he should change the password by choosing this option from menu. Of course, we required a strong password, and here we can see all details about it. What is important? We improved security policy by adding locking account mechanism by LDAP after 4 failed login attempts. When user account is locked, only admin can unlock in from view with user list. So, for example, if this user is locked, only administrator can unlock him using this button. The first step in Melodic usage is the defining of cloud settings. In provider settings menu part, we can check and update providers' credentials and options, as we can see here in cloud definitions for providers view. Filling these values is required in order to perform successful deployment because they are used in contact with providers. For example, by creating virtual machines instances. On my environment, I have already defined these values for Amazon Web Service and for OpenStack provider. Of course, it is possible to add such definition for other providers. For example, for Google Cloud Provider, for Azure, or Octawave, Polish cloud provider. In these definitions, we provide cloud credentials and also properties. For example, settings for Amazon security group or a set of private images which we would like to use in our deployments. When our platform is properly configured, we can go to deployment bookmark, where we start deployment process. We can see that our melodic machine is ready to use. So we can go to the next step. Before deployment, we need to model our application with its requirements in the Camel model, which is human understandable and editable form, described a moment ago by Marta. After that, such model is transformed by dedicated tool to XML format, form understandable for melodic. We upload such XML file here by drag and drop. After that, our model is being validated and it is saved in database. In this case, we can see one already saved model for application with name FCR new, and it was uploaded by me at the beginning of our meeting. In the next step, I need to choose which application I want to deploy and which cloud providers I want to use. In that case, I have only one model stored in database, and it is FCR new. Also, here is possible to run application in simulation mode. Simulation mode is the case when we don't want to deploy real virtual machines on provider's platform, but only check which solution will be chosen by Melodic. We manually set values of metrics in simulation part, and we can observe the result. It is used in order to check how Melodic reacts for our settings from Camel model. For example, for coefficients in utility formula. In an easy way, it is possible to adjust them to our expectations. But in case if our platform, if our aim is to perform a real deployment, I leave this option turned off. Then I need to select cloud providers. For example, I would like to deploy my application only on AWS. So I choose this cloud definition. Thanks to that, Melodic has credentials for this provider. Of course, it is possible to choose many cloud definitions in this step. Melodic has also one more interesting feature, which is named Bion. Bion shortcut means bring your own node. Melodic client can create own virtual machine and after that use them in application deployment. In such situation, Melodic uses this machine as node for installation on them particular application component. in Bion settings, it is possible to manage of such definitions. We can create new Bion definition by providing all required information needed for creating node. And there are such data as name, IP addresses, login credentials, and physical parameters of machine. For instance, a number of cores, memory, disk parameter, information about operating system, and also geographical location. After creation, such definition is available by application deployment. On my platform, we can see that I have already defined one Bion definition. And before starting the deployment process, it is possible to add it to our platform in order to use during this deployment. So by each deployment, user can decide if he wants to use some Bion definition or not. Of course, these definitions are saved on user's own melodic platform, and they can be changed and updated later, for example, during the next deployment. On my platform, I have already performed deployment. So when I can go to the next step, but I don't need to start the process one more, because it is already started and even finished, as we will see in a minute. And I would like to only describe it, so I don't need to start it again. So now please let me go to the deployment process overview. The first step of the deployment process is fetching offers. We have information about current total number of offers from previously selected providers. So in my case, from AWS. From these offers, Melodic will choose the best solution for each of our components. After choosing this box or offers option from menu, we are directed to detailed view about offers. And there are clouds with my properties and credentials to AWS, list of available hardwares with such parameters as number of cores, RAM, and disk, list of locations, and images. Here we can see only our private images, but of course, all public images are available for us. The next step of process is generating constraint problem. Constraint problem is generated based on our requirements defined in Camel model. In simple process view, there are visualized all variables from constraint problem with their domain values. FCR, so Secure Documents Application, which is deployed here on this platform now, is web application built from 3 components: load balancer, database, and application. This application stores encrypted documents using advanced distributed key encryption. User communicates with one load balancer, which divides requests between available application instances. All data are stored in one database. Melodic, based on metrics about application performance and user requirements, optimizes number of application instances. So here we can see that we have such variables as cardinality for each of components and also provider for each of them. Detailed data about constraint problem are shown after click on this box. And here are presented list of variables with additional information about component, type of this variable, and domain values, and also type of this domain. Utility formula. It is used for measure utility of each possible solutions and choose the best one. List of constants with types and values. They are created from user requirements and are used in melodic calculations. Here we can see, for example, minimum and maximum values for cardinality of component with application. So we would like to have from 1 to maximum 10 application components. We set such type of restriction in order to control costs of our deployments. And the last element here, metrics. They describe current performance of this application. Thanks to them, Melodic can make a decision about triggering the reconfiguration process, which means creating new additional instances or deleting not fully used ones. And now we can back to the process view. When a constraint problem is generated, it is time for reasoning. Melodic finds here the best, the most profitable solution for the problem defined by us. When reasoning is completed, we can observe information about calculated solution, so utility value and values for each variables. In our case, we have one application, exactly one database, and also one load balancer. And all of these components are deployed on the same provider, which was selected by me, so on AWS. And the next step in process deployment is deploying. Here, Melodic performs operations based on calculated solution. This solution is deployed. For each application component, Melodic creates proper instances, remains them, or deletes. If you want to have a more detailed view, it is possible to see process view using advanced view button. And now we are redirected to Camunda. Camunda is a tool for modeling processes in BPMN standard and for management of them. And it is used by us in our platform. I log in here by the same credentials are for the whole Melodic. Oh, I'm sorry. And now I need to choose our running process instances. Now on this machine, we have only one process. After choosing this process, we can see the detailed view of it. So we can observe each step of the process. And now we can see that after performing of each of these steps, we are at the end of our process, so our process is finished. This view is more for technical user, and also it is really useful, for example, during diagnostic of some problem. Our application is successfully deployed, so we can check the result in your application bookmark. In this view, there are displayed lists of created virtual machines and functions. Secure Documents application requires only virtual machines. We can see that Melodic created as far 3 virtual machines, so 1 application, 1 database, and 1 load balancer. These VMs are created in AWS EC2 in Dublin. Also, we have here button for web SSH connection to each of our instances. In case of serverless functions, which are also supported by Melodic, we would have data about name, state, provider, location, memory, runtime, stack, and the city where some, for example, AWS Lambda or Azure function is located. Also, we can verify if our VMs are really created in console of cloud service providers. So in this case on AWS. So now I go to AWS EC2 console, and here I can see my load balancer, my application component, and also my database component. And that's it of Melodic platform overview. I hope you find it intuitive and easy to use. So thank you very much for your attention.
Thank you very much, Alicia. I think you hypnotized our attendees. I don't see any questions and answers. I hope that it will be very soon. But coming back to our session, I would like to introduce our next outstanding speaker. It's Maciej Riedl. He will show you the deployment and optimization of the big data application to finish jobs of processing in expected time with the minimal cost. A few words about Maciej. He's a Java developer at 7 Bulls, involved in multiple projects concerning the AWS Cloud Spring and GPU optimization for machine learning. He has been working with Melodic for 2 years, responsible for implementing new features of the platform, as well as integration with additional cloud providers. So Maciej, the floor is yours.
Thank you for the introduction, Justine. Let me share my screen. Okay, hello. In this presentation, I would like to show you what happens when the application is already deployed. And as you can see, we are pretty much where Alicia has finished her presentation. When the application is already running. I want to show you that this application is not left alone. It is not just running, but it is. But Melodic can improve it, can monitor it, can gather information, and launch an extremely powerful reconfiguration process that improves it and finds optimal solution even later. To do so, I will show you an application that is called Genome. It is already started. It is a real case scenario, so I'd like to concentrate to stop here a little to explain it a little more. And it is an application that was prepared with collaboration of University of Białystok, Polish University. And it concentrates on analysis of large data sets, both concerning genetic and genome types of data. And it is important to say that the goal of those analyses is a selection of all relevant features based on binary decision variable. Sorry, and also, this genome application uses algorithm of exhaustive search of the entire space of tuples. And as you can assume, and because of the fact that the data sets are really big, the genome needs really big amount of computations to be performed, as well as quite big amount of resource usage. Fortunately, it is highly scalable, and we can use cloud resources for that. We would want to optimize the cost as well as the desired time to result ratio. And for that, Melodic would be just perfect. From the implementation side, Genome uses Spark, which is an open source engine for distributed computations. And it works really well with big data approach or parallel computations. So we would be using it. And the idea is quite simple. Like normally we would have multiple workers that want to perform scheduled jobs, and they communicate with Spark Master to pull them, and then they perform them. Luckily, Spark Master is the tool that is already integrated into Melodic, so we would not need to launch a new component. It is already a part of Melodic. As you can see here, we have the details of Spark Master here and the connected workers. We then go to Grafana panel, which is really important, which is a monitoring tool, also integrated with Melodic. And here you would be able to see the communication between the communication between Melodic and the workers. There are also a few details of the current configuration. As you can see, number of instances implies how many workers we currently have. But what is more interesting are the metrics. Those are the information we gather from each worker, and they pretty much can be everything we want. They had to be specified earlier. So normally they could be like CPU usage or RAM usage, but here in this specific scenario, we concentrate more on those computations, how they are performed, how long time does it take to finish them, and also how much time is left. I mentioned before that we need to optimize time to result ratio. And as you can see, we started with almost 600 jobs, which is quite a big amount of computations to be performed, and with 1 hour to perform them. We also started with 1 worker as a starting configuration. And what happens here is that as long as the application works, it may happen that this worker is not sufficient, that following computation needs more resources. And this is what happens, is that Melodic counts new values for minimum cores, how many new values are, how many new virtual machines would be needed. And based on that, it estimates time of how much longer is going to take to finish all the configured jobs. As you can see, currently, like the estimated time is pretty similar to the time that is left. And when the estimated time would be bigger than time left, which may happen when computation takes too long, the Melodic can choose to launch reconfiguration process. And in this scenario, it would based on those metrics, it would see if a new configuration is needed. I would then go to Melodic view deployment view. I would just point out that currently the estimated time is too big than time left. The color has not yet updated because we have a bigger refresh time. We would then go to Melodic deployment, to process view. Okay, as you can see, one of the configuration process has been ended, as multiple of them can happen after the application is already launched. And like when you see those blocks, they're quite similar to what you have seen during deployment. And they are pretty much the same, but now we have more knowledge, the important knowledge. And this important thing happens in reasoning, where we have the values of those metrics. And for example, this minimum cores values, those estimated time left. And based on that, Melodic can find a better solution for current situation, because the one chosen after deployment, after the application has been running, turned out to be not proper for this current situation. And this is exactly what happened here. after reasoning with more data, a new deployment has been, not new deployment, but new virtual machines have been added because the amount of them was not sufficient. As a reminder, we started with just one, and then we communicate with the cloud to start new virtual machines. I'll go back here. Here you can see like the number of instances that was increasing over time. We started, as I mentioned, with just one, and over time we had, it seems, 2 reconfiguration processes. First increasing the amount of them to 2, and then increasing the amount to 3. And that would result in a situation that the estimated time would decrease. And which is important, like the situation, if Melodic finds suitable to start another reconfiguration process to find a better solution, it will do so. Or we can show in instances AWS list that we should have here more instances. I remind you that we started with just one, now we have 3 workers. I'll go back to here. Okay. And as I can see, currently the estimated time after those 3 reconfigurations is sufficient for us to fulfill all the computations on time. It is also worth mentioning that Melodic can decrease cost. So if it finds that the current solution is good for us, but we can decrease the amount of virtual machines, it would do so. Okay, I hope I have shown you that the application is not just left alone after it is deployed, but that Melodic can handle it over time and improve it, even without our decision to make it better. Thank you.